A 50-gram bullet moving east strikes a 1.3 kilogram block on the right and becomes embedded in it. The bullet block system rises 4.5 meters above its initial point. How fast was the bullet traveling before it collided with the block? All right, so let's draw a picture. So here's my block. Here's my bullet moving this way. And then right after it hits, so right immediately after the collision, I'm going to have, right, so this is like my before, and this is my after. And then I have, it's talking about the combination rising to a certain point. So let's draw that as like that. And now we're going to say that this is our y equals 0, and this is our y final. And they tell us what y final is. So the before and after, so this is before and after for energy. And this, the left side, is the before and after for momentum. Okay, so our givens, we have our mass of the bullet is equal to 0.050 kilograms. Our mass of the, we'll call the block capital B, is equal to 1.3 kilograms. We know that the y final of the bullet in the block is equal to 4.5 meters. And so for our fines, the first thing, it's telling us that what our y final is. So I think the first thing we need to know then is we're going to work backwards from that y final, and we're going to find the final velocity of the bullet block combination right after the right after the collision. So we're going to find this, the velocity right here, right after the bullet hits the block. So we're going to do that first. So we're going to find v final. And then after that, we need to find the speed of the bullet right here. So we're going to find that first and then this second. So VI of the bullet. So let's call this one A and this one B. So we'll say, all right, for A, let's start with A, and we're looking for V final. So we're going to start with conservation of energy. So that's how we're going to find V final. And so we're going to say, okay, for conservation of energy, we know that K initial plus U initial is equal to K final plus U final. And so initially, right here, we know that our Y is equal to 0, and so that means we have no potential energy. And we know here, right here, right, when we get to the highest point, we know we have no kinetic energy. So that's equal to 0. So we're going to have plugging in 1/2 mv initial squared is equal to mgy final. And so we're looking to find that this v. So we're going to cancel out the m's on both sides, and then we're going to multiply both sides by 2 to get rid of the 2 on this side. And so I see that v initial is equal to the square root of 2 times g times y final. Plug in numbers, v initial is equal to the square root of 2 times 9.8 meters per second squared times 4.5 meters. And so v initial is equal to 9.4 meters per second. Okay, so that's my, I said v, what is my v final? And so I'm calling it v final for my collision experiment, but my collision piece of the problem, but what I solved for was what is the velocity right here, right when it leaves, right after the bullet gets embedded. So that's what I solve for. And so that's going to become my V final for the collision part of the momentum part of the experiment. So I'm going to use this V initial from the energy to be my V final for momentum. Okay, so we're going to start on the momentum. So I know for momentum, starting on B, I have momentum initial is equal to momentum final. And so I know that I have M of the bullet, V of the bullet initial, plus M of the block, V of the block initial is equal to M of the bullet plus M of the block times V final. And so I know the block starting out is 0. So I'm looking for, this is what I'm looking for. Remember, I'm going to use for this V final, I'm going to use this V that I calculated from the other part of the equation, or the other part of the problem. Okay, so V final then is equal to MB over MB plus M of capital B. So I just divided both sides here. Okay, cancel. So I'm solving for my V final. And that's times V of the bullet initial. And so, oh, I did the wrong thing there. I'm not looking for V final. I have that already. Just erase that. So I'm going to, so scrap that and this. So I'm looking for V. I'm just going to rewrite that. So our equation is MB VB initial is equal to MB plus MB times V final. I know this V final, and I know these, so I'm calculating VB initial. So VB initial is equal to MB plus M block over M of the bullet times V final. So I plug in my numbers, and I get VB initial is equal to, let's see, that's going to be 0.05 kilograms plus 1.3 kilograms divided by 0.05 kilograms times 9.4 meters per second. And I solve and I get 253.6 meters per second. So that's the speed of the bullet in order for the combination of the bullet and the block to rise to a height of 4.5 meters.